Okay, so let's take a look at these. The top one up here is just addition, so we're going to line this up just like we would any other subtraction problem, I should say. So we are subtracting down the columns now. So this is 11 minus a negative 7 is positive 18. Good. Negative 3x minus 9x, negative 12x. Good. 7x squared minus 12x squared, minus 5x squared. There it is. How many of you had that? Good deal. Then the multiplication, doesn't really matter what order I put them in here. We're multiplying. 7 times negative 5, negative 35. 7 times 4x, 28x. 2x times negative 5, negative 10x. And 2x times 4x, 8x squared. So we combine, we got negative 35. 28 plus negative 10 is positive 18x. And 8x squared. Any questions on that one? So let's look at something like this. How would we do something like this? Or what could we do with something like this, I guess I should ask. Combine like terms. Combine things with the same name. So how about the 7y? Is there anything I can combine with that? 3y to make 10y. Anything else I can combine? Okay. This is not 9p, though. It is negative 9p. And positive 2p make negative 7p. Now we do have to remember to have an operation, either a plus or a minus in between those to link them together. Since it's a negative 7p, we have the minus in there. So it is 10y minus 7p. We could run into things like this. (42) a to the 5th, b to the 9th, divided by 7, a to the 4th, b. As I divide this out, I'm going to combine the counts. 42 divided by 7 is 6. And then I combine the names. A to the 5th divided by a to the 4th. What do we do with the powers when we divide? Subtract. What's 5 minus 4? 1. So a to the 1, or just a. And then b to the, we think of this as b to the 1, so 9 minus 1 is 8. So b to the 8th. What if we have something like this? We're dividing that out. Well, we might be more used to seeing it. Most of the examples we did when we did this in class probably looked more like this. Put the 4x underneath it like that. Same thing. So now, 8x to the 3rd divided by 4x. Well, what's 8 divided by 4? 2x squared. Negative 24x squared divided by 4x. Minus negative 6x. Good. And 20x divided by 4x. Positive 5, so plus 5. So there's our result. All looking familiar? What's that going to become? X to the 45. When we're multiplying, we add the powers. How's about something like, let's do this. Well, something like that. Well, I can either do the distributing like that, or I can write it out. Perfect, yeah. 7 times 11, or 7x times 11y is positive 77. X times y is xy. 7x times 3x is, 7 times 3 is 21. X times x is x squared. Or you could have did the same thing here. 7x times 3x is 21x squared. And 7x times 11y is a positive 77 xy. Same answer. What do y'all think? Good stuff? What if we throw in something like this? We're just multiplying, so we combine the counts. What's 15 times 4? 60, right? And then we combine the names, but we do each name separately. So we've got x to the 5th times x is going to make x to the 6th. Remember, we treat that as x to the 1, so 5 plus 1 is 6. And then y to the 7th. Very good. How about this? X to the 32. Very good. When we have a power of a power, we multiply the powers. Yes. How about this? Does that become 30? No, it is not 5 times 6. It's 5 to the power 6. The number still has to do the operation. 5 to the power of 6 is 5 times 5 times 5 times 5 times 5 times 5, or 15,625. Now for the x's, it's multiplying the powers. X to the 4th to the 6th power is x to the 24th, and then y to the 54th. Yes, I don't know why, but I said 50. Don't know where that came from. What do we do with this one? Correct answer is nothing. How about this one? Correct answer is, again, nothing. The answer is 3 plus 9x. The first one, the answer is 4x plus 7y. Nothing you can do with it. The good news is you guys should now, what's that? Or 7y plus 4x, yes. The good news is now you should be ready for a quiz. So there are a couple of you still working on the quiz. Oops. Maybe not for very long. Thank you. Thanks. Okay. I passed out a packet to all of you, and there's really nothing new in this packet. It's just dealing with the symbolism on drawings and stuff like that with variables. So we're going to be going through, it deals with what we've done, dealing with the variables, converting English into the symbols. Starting out on page 158 there on the bottom of the page. Your first several deal with that. Then it gets into looking at drawings and creating an expression for dimensions on the drawing from the symbols that are given. For example, let's say we take a look at problem number 8 there, just because it's relatively easy to draw, and I'm pretty sure I can draw it without screwing it up too horribly. Okay, so you got 3x, 4x, y, and 5. And point A is right here, and point B is right there. If I want to write an expression for the total length of this object, well, that's just going to be adding up all those dimensions. 3 plus x plus 4 plus x plus y plus 5. But I'm not going to leave it that way. I should simplify this. So obviously I can combine 3, 4, and 5 to make 12. Anything else I can combine? X and x to make 2x. Yeah, think of that as 1x and 1x. Add them together, I got 2x. Just like 1 inch and 1 inch make 2 inches. And y. So 12 plus 2x plus y. If I just wanted to find the dimension from A to B, well, I'm going from here to here, that is just going to be x plus 4 plus x, or combined to make 4 plus 2x or 2x plus 4, either way. Number 12 is kind of interesting. We talked about these a little bit earlier. This is a hexagon instead of an octagon. We dealt with the octagons and their special formulas in our area and volume and perimeter packet. Here's a hexagon, so it's only 6-sided instead of 8-sided. Pretend that circle goes around there and it exactly touches the vertices of the hexagon, and pretend this circle perfectly sits inside of the hexagon. While you're at it, pretend it looks like a circle. So anyway, what we have is we have S, which is the length of the side of our hexagon. Then we have capital R, big R, is the radius of the big circle on the outside, and little r is the radius of the little circle on the inside. So what we're asked to find here is some expressions. Like part A, what is the length of R if R equals the product of 0.866 and the length of the side of the hexagon? So little r equals the product of 0.866 and the length of the side of the hexagon is just, product means you do what? Multiply. So 0.866 times s, or 0.866s. Part B, what is the length of capital R if R equals the product of 1.155 and the radius of the in circle? So capital R equals 1.155 times little r. Because again, it says product, so it's multiplying. What is the area of the hexagon if the area equals the product of 2.598 and the square of the radius of the outside circle? So the area of the hexagon equals the product of 2.598 and the square of the radius of the outside circle. So is that times capital R? It's capital R squared. Very good. You can actually find the area of that hexagon from either capital R squared or little r squared or s squared, either one. Any of those three. There are different numbers. The 2.598 would change, but you can find the area from any of them. There's evaluating formulas. You might have something like this for A equals 5. Oops, this is a C, not an E. And C equals 3. So I have to replace those values. A is going to be 5 plus 5C is going to be 5 times 3. We're going to write it out for now. We'll do the operations in a second. AC is going to become 5 times 3 plus A is 5. Now we'll go back and do the operations. So on fraction bar says we'll do everything on top first. What do we do first up there? Yeah, 5 times 3 is 15. Then we can do 5 plus 15 is 20. On bottom, we have to do 5 times 3 is 15, plus 5 is 20. So 20 over 20, this is 1. That looks familiar, I hope. Or we can get into something a little bit uglier, like p to the third plus 3p minus 12 over m squared plus 15 for m equals 5 and p equals 4. Yeah, it's m equals positive 5. Yeah. So, substituting in the numbers, this is going to become p to the third is going to be 4 to the third plus 3 times 4, 3p becomes 3 times 4 minus 12. And then on bottom, what do we have? M squared is 5 squared plus 15. Now we do everything on top first. What are we going to do first up there? 4 to the third power, which is 64. Then what? 3 times 4 is 12. So then 64 plus 12 is 76. Minus 12 is 64. On bottom, first thing we need to do is 5 squared, which is 25, plus 15 is 40. 64 divided by 40, 1.6. What do you think? Still better than a sharp stick in the eye? Okay. There are all sorts of formulas out here that in this packet that describe areas, dimensions, lengths, perimeters, and all sorts of good stuff like that. Starting on the bottom of page 158, I would like you to do all. We did go over a few of them, but I would like you to try to do all of them because they're all formulas that are really good for you to be exposed to. So 1 through 28. Of course, you don't have to redo the ones that we already did.